Hi everyone, and welcome to a webinar on why C++ Builder, some of the benefits and advantages and solutions that you get when you use C++ Builder. Just before we begin, if you're joining us on GoToWebinar, then all the microphones are going to be muted, but feel free to ask questions. We have a Q&A panel on the right, and you can type in there and we'll answer them at the end. If you're watching on YouTube, then there will be a live Q&A at the end, and stay tuned to hear what people asked. Hopefully they'll have the same question that you did. My name is David Millington. I'm the C++ Product Manager here at Embarcadero, and you can see my email and Twitter on screen. Feel free to contact me anytime. So we're going to look at a few things today. First of all, a very brief introduction to what C++ Builder actually is. Then a longer examination of some of the problems that people often encounter when doing C++ development. Then some of the things that C++ Builder does that will solve these problems for you, followed by a brief look at C++ Builder's roadmap, where it's going in future. So C++ Builder is a multi-platform C++ IDE and development environment. It runs on Windows, and you use it to build applications that can target Windows, iOS, Android, and macOS. It has fantastic UI design tools, and we'll talk about some of those later. But a brief overview that FireMonkey, which is our Crossplatform Yui framework, is GPU-powered and stylable, gives you access to native controls, and is very easy to customize for a huge variety of different devices, and naturally is cross-platform. And we also have a large number of very elegant and performant libraries, database, JSON, REST, other communication, general RTL, and other libraries that you would use. So the result here is that you have a very powerful environment, a very powerful cross-platform C++ development environment. We're going to look at just one thing today, which is writing a cross-platform C++ application. Now, C++ has many different compilers and IDEs on lots of different platforms, and on the surface of it, that might make it seem like writing a cross-platform C++ app is easy. Of course, if you've tried this for any non-trivial C++ application, you'll know that that's not true. Let's have a bit of a look at what can happen about why cross-platform C++ is hard. Well, to start with, you'll probably end up using multiple IDEs. For example, you might use Visual C++ on Windows, Xcode on Mac, C-Line anywhere. And that will give you a whole bunch of different experiences. You'll get used to different shortcuts and different debuggers and different ways of doing things. There's a big productivity hit when you have to change and adapt constantly depending on the actual platform that you're trying to debug or code for at any particular time. You'll also end up with multiple compilers, MSVC, GCC, Clang, perhaps even something like MinGW, each of which has their own runtime, so multiple runtimes and standard libraries, and all of these will have slightly different behavior. And this one is particularly damaging because of the huge impact it can have when your compiled code, the same code, the one set of code that you have, can have different behavior on different platforms with different compilers and different runtimes, especially when it's an edge case or something unusual, something that can take quite a while to actually track down. The user interface, though, is probably the largest and most visible problem that you'll have when writing a high-quality C++ app. Typically, you'll rewrite or redesign the UI on each platform. And that means you'll use multiple tools again. You might even end up using multiple languages and have to hook up different languages to your C++ core. Sometimes people use other libraries like Qt or WX widgets or something like that, all of which are cross-platform UI frameworks, but they are all non-platform standard everywhere. And so you'll get a non-standard look and feel and behavior on every platform. So you can't get an app that fits in. Every target will be, the app for every target will be almost right, but not quite. And if you want a high-quality user experience, you need to give an application to your users that looks and feels and behaves as though it matches the OS, the platform that it is running on. There are a whole bunch of other libraries that you might use. I'm looking at database ones here, and they're often complex. There's some good cross-platform database libraries, but they can be very complicated to set up, and there are scenarios that they don't handle well. One surprisingly common one is when you need to mix multiple different databases. So here's where that leaves you. You'll use multiple IDEs with multiple compilers and multiple runtimes, and you lose your consistency. You lose the consistency of your experience every day, of your working experience. And that directly leads to lost productivity. And when you constantly switch between different IDEs and different compilers, and when you have to debug bugs that occur only on particular platforms, it's a waste of time, a waste of mental effort that you could use elsewhere. UI is important because consistency is important there as well, and in this case it's consistency with the platform that you're running on. If you write an app for iOS, then it needs to look and behave, it needs to feel different than the same app running on Android. And of course there are other libraries, database ones particularly, but many other libraries that are cross-platform but have their own pros and cons and may not work as well as you would really like. So here's the key with C++ Builder. C++ Builder solves every one of those problems. C++ Builder is one IDE, one developer platform. From it you can target all platforms and devices, so you can design and preview that design on any device. You can deploy to any device and you can debug on any device. You do all of that from one place. You have one compile experience and one debug experience. You run the same code everywhere. So CBuilder uses Clang-enhanced compilers for Windows, iOS, and Android. So you can share one compiler with one set of behavior, one runtime library, and one set of cross-platform libraries. And that means that you'll always get the same behavior because you're running the same code on every platform. You don't need to relearn multiple single platform libraries. You can learn your libraries once. And you don't need to track down bugs that only happen on one device. You can have consistent, reliable behavior. Greatly cuts down your development and debugging time. We have a fantastic cross-platform UI. So if you rewrite your UI layer in a new language and a new framework for every platform, you don't have to anymore. Or if you use a single UI framework like Qt or WX widgets, then you will have lost the platform native look and feel for your users. Now for both of these, we have FireMonkey. You can see in the screenshot on screen an application that's running on both an iPhone and a Windows desktop. And it's the same application, but on the iPhone it looks like a real iPhone app. It behaves like it as well. Your users will use it and feel that you have a high quality, fantastic user experience, iOS user experience on the iPhone. Users on Windows will see something that looks and feels like a real Windows application. It too will be what they're used to. So FireMonkey is a cross-platform UI framework. It is GPU accelerated, so it is fast and speedy, and it is stylable, so you can make it look like whatever you want. But it also gives you access to native controls for the real native look and feel. Right now that's for Windows and iOS, and Android and macOS are on the roadmap. So you can see on the screen we have the designer and a couple of apps running on Windows, so the same app with different styles. Now, if it's important to you that something like an edit field, a text entry field, is native on Windows or iOS, then you can do that. And you can change the edit so that when the app runs, it will be the real native implementation. And we have very high quality widget implementations that we believe provide a very high quality user experience. But one of the founding principles of FireMonkey, in fact of all our libraries, is that you can always access under the hood if you need to. And we often expose that directly as well. One of those ways is that if you want to use a native widget, then you can use a native widget. FireMonkey also allows you to design a UI once and then tweak or change per platform. So you might think, for example, that if you want a desktop app and a mobile phone app, then you need to design the UI twice, because those are two very different devices. With FireMonkey, you don't have to. You can design your UI once and you can hook up all the controls and events and have your UI and logic layers. And then you can tweak or change per platform. This is a little like subclassing per platform. It allows you to build it once and then modify the UI, including the layout or including adding controls or changing properties of controls, anything like that, per platform. So you can then create your UI quickly. Then you can create a mobile UI, and then you can tweak that mobile UI differently for iOS and for Android. This saves a huge amount of development time, and it also leaves your users with the top quality native look and feel and experience. Here's a screenshot of the IDE running. You can see the designer in the background and a Windows target of the application running in the foreground. So you can see how well FireMonkey can be styled and how well it can be customized. The red highlighted area here is where you change the views. So you can change the UI layout depending on the platform that you're targeting. Here we're editing the master view. That's the original view. If you want, you can choose Windows Desktop or you can choose iPhone. And then you can tweak the UI for that particular platform. Finally, C++ Builder comes with a fantastic set of cross-platform, elegantly usable and well-designed libraries. So one example is you need to do database access. There are lots of powerful database libraries for C++, but how many of them are actually easy to use? What happens when you change databases to a different database technology? What if you add a second database and you need to mix the two? What if you move your app to Android and suddenly need a new database library because the C++ library that you're using has never actually been built for Android? Our answer here is a database library called FireDAC, which is cross-platform. Just like everything else that we write, you use it once and it works everywhere. It supports 17 common databases. If you're using Oracle, if you're using MySQL, if you're using Postgres, or if you're using any one of over a dozen others, then you can use it easily. You can even mix multiple database technologies in one application, even joining between tables in different databases. And it's well designed, elegant, and a pleasure to use. That means that you can write an app for Windows. You can decide that you want to port it to iOS, for example. And because you've used FireDAC, that is easy. You don't need to redesign or rewrite any of your database layer. We have similar libraries for other things, such as JSON and REST and more. C++ Builder comes with a solid, featureful, and elegant cross-platform library set. It's something that you can use, has consistent behavior, and it runs and works well on every platform that we support. So that's C++ Builder. There are a whole lot of problems with good cross-platform C++, with creating a consistent and well-designed UI, with creating a fantastic user experience, with your development productivity, with just the time that you spend in development. All of those are solved with C++ Builder. You use one IDE and one compiler toolchain. You can create great UIs with half the work using FireMonkey. You can create cross-platform and elegant database code with FireDAC. And C++ Builder includes everything that you would expect. It uses Clang. It has CMake support, it has a package manager called Getit, it has a community edition. Before we go on to the roadmap, I'd like to give you a quick look at what C++ Builder looks like in practice. So this is C++ Builder 10.2.3 running in front of you. This is in the dark theme. And we have a number of FireMonkey templates. They're sample apps which you can use as a basis for your own apps if you want, or to see how things are built. All of these were built by a UX designer and showcase how to create some fantastic looking applications. So I have one here. You can see it in the designer. You can select items, so selecting a label here. In the object inspector on the left, you can see that the label has a number of properties which I'm scrolling through, including, for example, text. So I can change the caption by typing there. This is pretty much everything you would expect from a normal UI design tool. Now, when I run this application, Here it is running in Windows. It looks very nice. Let's have a look at another. Let's look at sample project number 3 for home project. Here means that it's an example of a home screen in an app. This is its main form, and as you can see, it's also available in the form designer. You can do something like select a label or an image or something like that. Now these sample apps don't have any actual functionality, they don't have any behavior. They're simply here to illustrate the UI design that you can implement yourself. Of course, you can attach events and that kind of thing. If you go to the object inspector here on the left, you can see a whole bunch of events such as onClick, and you can attach an event by double-clicking, and you'll have some C++ code, and you can use this to hook up your UI to some kind of backing logic. Of course, you'd normally try to have a good UI and logic separation layer. But for right now, let's just examine what that looks like when you run it. Here it is again running on Windows. Really nice looking application. If I click the hamburger icon on the left, you can see that a menu slides out. You can place whatever you want here. Of course, if we click in this gap to the right, this is the equivalent of tapping. If this were running on a phone, then that menu disappears. Fantastic example of the kind of UIs and kind of application that you can easily create with FireMonkey. Now let's have a look at creating an application from scratch, just to show you some of the more fundamental basics. Let's go to File, New, and I'll create a new multi-device C++ application. Just choose a completely blank one. So this is our design surface. It's the form, it's what will become a window when the application is run. Of course, if you're working on a mobile device, it will fill the entire screen. In the bottom right here, we have the tool palette with a number of categories, so you can add a number of components. Here I'm going to add a button just by double-clicking, and I have a button on screen, and perhaps a checkbox as well. There are any number of components, everything that you would normally expect is present, and we have a good third-party ecosystem for creating lots of third-party components. You can even write your own if you wish. The key to notice here is that when you place something on the form, you can drag it around, you can place it, you can resize it, all that kind of thing. And the number of properties on the left here that change how the control behaves or how it looks. There's also the event tab, which is where you hook it up to code when something happens. I showed the onClick event earlier. There's of course drag drop, and when focus is entered or exited, gestures, mouse interaction, that kind of thing, to control painting as well. Everything that you would normally expect. Now if I run this application, it looks pretty plain. Now I want to show how to use the views for different devices, and I also want to show how to use a native control. So I'm going to add an edit box. Now here, this is a FireMonkey edit control, and you can enter text. What we want to do is we want to have a view where we change the UI, we tweak the UI for the Windows desktop. So this application could run on Windows or iOS or Android or Mac, and it could do so on a variety of window sizes, screen sizes, depending on whether it's a phone or a tablet or a normal desktop. Now the master view here is where you create your basic UI, but you can customize it per platform. Now I happen to have only Windows installed right now, and I'll show you how to install other platforms in a moment. But if I change the view to the Windows desktop, I can now customize this application, and every change that I make here will only apply when I run the application on Windows. So I want to demonstrate this a couple of ways. First of all, I'm going to change the position of this edit box so it goes up in the top right. So you can see I'm changing the position only for the Windows desktop. Second, I want to go to the properties and I want to choose the control type. You can see here currently it's styled, and I want to change that to the platform style. we immediately have a small overlay here indicating a device, and that means that this is now a platform-styled control. And that means that it is now the actual underlying real native control. So when I run this, because I'm running on the Windows desktop, we should get a layout that looks like this, with the edit box in the top right, despite the fact that the master, the original layout, had the edit box elsewhere. Second, when we run it, we should be able to see some native control behavior. So I can type into this, and if I right-click, you will notice that I have the IME controls that are built into the real Windows native control. And of course, this is fully seamless. You can't tell by looking at this that this is a native control and this is a FireMonkey implemented control. Finally, I want to very quickly show our package manager. Go to the Tools menu and then Get a Package Manager. This opens up a window with a vast number of libraries and controls. You can see a large number of categories here, such as components, Internet of Things, industry templates, IDE plugins, sample projects, that kind of thing. The connectors are worth looking at. These are used for FireDAC and let you access any of over 100 different types of data sources, anything from Facebook to Twitter. You can see here we have a beta one for Instagram and more. So FireDAC, which I mentioned earlier, supports about 17 different databases, but you can use one of these to directly connect to a data source and interact with it exactly as though it was a database. Amazingly powerful. Finally, I want to show you how to install support for other platforms. And if you go to the Tools menu, we can go to Manage Platforms. And this lists the available platforms that we can install, obviously enough. Right now, as you can see, I have Windows 64-bit and 32-bit installed. I can also install support for macOS, iOS, and Android. All I need to do is click the checkbox and click Apply. And that will install support for building for iOS as a target. So I can then add an iOS view to this form, and I can compile and build and deploy straight to an iOS device, including debugging on the iOS device right from within the IDE. Exactly the same for macOS or Android. So just to reiterate, same slide again. Hopefully it makes even more sense now that you've actually seen C++ Builder in action. You can create fantastic cross-platform, excellent quality C++ applications with C++ Builder. You have one IDE, one compiler toolchain. FireMonkey is fantastic, really flexible and powerful UE framework. FireDAC and our other libraries are amazingly flexible and elegant as well. I even showed you some of the C data connections that allow you to talk to all sorts of different data sources through FireDAC. And then a whole bunch of things that we just haven't had time to go through today, such as the fact that we use Clang-based compilers, our CMake support, and that kind of thing. Finally, let's have a look at where C++ Builder is going. Let's have a look at the roadmap. So this is going to be just one slide out of many from the last published roadmap as of August 2018. Now, C++ Builder is part of RAD Studio. We have a second language called Delphi, and you'll also see that on these slides. So C++ Builder 10.2.3 is the current version that you can download right now. We added some rather cool things to that, including command line CMake support and C++ rename refactoring. The next version of C++ Builder is 10.3, and we planned some rather good things for that. We have our Clang upgrade to support C++ 17 for Win32, and of course we constantly focus on performance and other enhancements, and we'll have a number of RTL changes, especially to do with performance this release as well. On the more general side, we mentioned earlier that you can have native controls in FireMonkey for iOS and Windows. And the macOS and Android were on the roadmap, so the first step towards that is coming in for Android this release as well, to be followed up in a point release afterwards. And of course, as you can see, going on 2019 and mid-2019 and onwards, a number of other excellent enhancements. So that's C++ Builder, a fantastic product. One IDE, you target many platforms, has Clang-enhanced compilers, it has excellent cross-platform UI done right, and fantastic database and other libraries. You can get a free 30-day trial at embarcadero.com/products/cbuilder/start for free, or you can try the community edition at embarcadero.com/products/cbuilder/starter. C++ Builder for the Enterprise and Architect editions is currently on sale through the end of this week. That's until Friday the 31st of August at 35% off to celebrate C++'s 35th birthday. If you have questions, please type in the Q&A panel to the right, and we're looking forward to those. Thanks for watching. We'll hand over to Q&A now.